sorry, I was going to start once we began presentations. This works more. But again, yeah, welcome everybody. Congratulations for making it to the finals. It's very exciting. We really loved working and looking at your projects. And they were so good, we thought that we should present them and see what's going on. So our three judges are here, Howie, Yuan, and Avi. Their introductions were obviously in our intro session, also on the website. And we are really excited to have them here. Also with us is our CEO, Masi. So hello, Masi. But yeah, there is no particular order for the first, second, third, fourth presentation. So we're just going to simply go by the order that was on Discord, if that's okay. And since I believe all the team members are here for Caillou's side, maybe we can start there. How does that sound? You guys can come off mute, Caillou's side, if that's okay.
And we would like to ask maybe to present up to 4 minutes, 3 to 4 minutes, so that everyone can get can present. So and judges might have some questions as well.
Yeah. Hello everyone. I'm Aman. I'll be presenting for QSE. Can you all hear me? I just want like a audio confirmation.
Okay. Yes. Did you Aman? Can you share your screen?
Yep. Just a sec.
Sure. Take your time.
Can you all see the screen?
Yes, sir.
Okay. Our project QSE. While opening up the hackathon, while coming up with the hackathon ideas, we realized that Metabob API is really useful, especially when tackling issues and problems with code in certain repositories. But one special thing we thought about was personalizing based on users. So while going through the API itself, we realized that it was supposed to be meant for a particular user's public repositories. We realized that if we compared and we use predictive analysis and pattern recognition, we could better understand a particular user's mistakes or issues which he continuously repeats across different repositories, which is why we used clustering based on word embeddings, specifically statistical tools such as bag of words. We use bag of words for enabling this clustering, which is closely related to the topic modeling topic. However, instead of using word embeddings, since the data distribution itself was so wide, we were not able to use any pre-trained model. Therefore, we use bag of words, which is simply a query-based statistical tool for embedding for numerical representation of issues and explanations. Now, for example, if I display, say these, we basically show you the public repositories which are currently provided by the API itself, and say we select a bunch of them, say bouquet, dash, maybe TQDM and rich, and we we categorize, cluster them, and we can basically represent them into different sets. Including other repositories, we can definitely define other variants of the data set, allowing better understanding and representation of the issues presented within it. Now, our analysis basically allows the, our analysis basically allows the user to better formulate which repositories may or may not fall under particular categories. Because of the theme of the hackathon, we represented it in a space like pattern, representing them using stars and coloring different repositories with their own respective colors. Thank you. If anyone, if you all have any questions, we are ready to answer.
So when you try to build this embedding map in the two-dimensional space, so I can't see it very clearly, but looks like let's say we just pick the pink color. Are they all coming from the same repository? What?
No, yeah, the ones with the same color, they all come from the same repository. And yep.
Yeah, so I think, one interesting thing is we love to see certain, we love to see some points that are similar that can be clustered together, but seems like at least on the diagram you should hear, they kind of spread out together, mix up together. So really from particle perspective and how we can use this information if we see diagram like this.
Yeah, for example, although we do not specifically show it, we we display ref IDs of those which have been which have been clustered together. So we were not able to deploy the API in such a way that you could click the particular ref IDs and it would display the issues side by side. However, we do list them out so that in the future we may allow that kind of a solution, that kind of a demonstration where two similar ref IDs can be displayed next to each other, allowing better comparison.
Right. Yeah. Okay.
Are there any other more questions from the judges?
None for me. Howie, do you have?
I'm
any
good.
questions?
I'm good.
Overall, I think it was a fairly well put together project as well as a good presentation. So, kudos to you.
Yep. Good idea. Good visualization.
Thanks a lot.
Yep, good job.
Fantastic. All right. Well done, guys. Thank you so much.
Thank
you.
you.
Go ahead. You can go ahead and stop sharing if you don't mind. Okay, perfect. Thank you. Our next presentation will be, thank you. Our next presentation will be Clybug. So Clybug, if you want to go ahead and.
So, hi folks. So we are a team of 4. So what an exciting day, folks. Amazing 24 hours of working on this project.
Yeah, it's quite an amazing job that we have done it. I mean, yes, we still have those energy and vibes to work. So first of all, thank you for having it.
Exactly. We must thank Metabob for organizing this and bringing us all together. So here, what happened, we came across this cool debugger API Metabob to debug our repositories, but implementing an API with repetitive code is quite redundant. So this inspired us to come up with this command line interface debugger, which we call CLI-bug or Clybug. So Yasin, why don't you introduce us to Clybug?
The CLI-bug, it is like a very handy command line interface tool for the developers to access the API from the command line itself. So we can pull out the repos from the command line itself. We can search by the we can pull out the repos from the command line itself. We can search by the name, and we have done some implementation that will make the API very handy for the developers which are working on the command line. We can directly go for get repo by name. And the thing we just intended to implement this. The developers can have a small extra layer on top of the API, and they so that they can directly interact with the API and adding some extra functionalities that can be implemented. Like we can get the repo by its name itself, and we have done some other implementations too. Yeah.
To add on a point on this, we do have a documentation README file where we have mentioned about the you can see on the screen. We do have this documentation that we have mentioned about the functionality that we have added to the CLI thing, and the entire idea about the project is making as a developer, you definitely prefer working on the command line. Like, I'm a new guy, but I've seen people like they're working, they like working in some command line. So the idea was to give them that feel for this particular API also. So yeah, that's all from the project. Thank you.
Awesome. Thank you so much. Judges, do you have any questions for Clyde?
I don't have a question, but I agree with what the team said, that as a developer, you need a CLI. So sounds a good idea to me.
Thank you so much.
Oh, the documentation was good too.
Thank you.
Thank you, sir. So
yeah, thank you for taking the time and creating such a cool
Hey,
wrap.
have you used Metabob before? Before the competition today, have you used the Metabob before?
No, sir. So basically, I would say we were unaware about anything that we are going to do about this API thing. So we just came and we started working on this API, and lately
we found this very cool, and we were just brainstorming about it, and then we came up with this idea so user doesn't have to implement the redundant code over it, and wherein he can directly use it in the command line interface.
Yeah, I think it's very useful.
Thank you so much.
Thank you.
Awesome. Yeah, Clyde, thank you guys so much. You can go ahead and stop presenting. Perfect. Okay. Thank you again. Our next group will be automatic issue. Automatic issue, you can go ahead and start sharing your screen whenever you want.
Hello.
Hi.
Hey.
I just want to make sure like my project is automatic issue creator on Jira. I just want to make sure if that's the project you guys are referring to.
Yes, that's the one we're referring to.
Okay. Hi guys. Let me just share my screen.
No worries.
Okay. Okay. Can you guys see my screen?
Yep. You good?
Yeah. Okay. Hello guys. First of all, thank you for this hackathon. I had a really great experience. I learned a lot of things. When I first saw the the kickoff session and learned Metabob, I learned a lot of things. I found it really interesting that Metabob actually can go on a deeper level to find bugs and performance things that you wouldn't normally find on any other tools. So I just found that really interesting. And when James gave me a workshop on how to pass the API using JavaScript, the first thought that came into my mind was all the issues that are being generated by Metabob. I think it's better we could create automatic issues on like a popular tool such as Jira, where you can totally focus on issues and you can be faster by assigning those issues to certain developers there, whatever the respective developers, whoever it might be. So that was my first thought. So when I thought of that idea, I didn't even know that if it was possible to do it in Jira. So while I was browsing online, there is Jira offers its own REST APIs. So my first idea was to interact with the Metabob's API and also with the Jira's API to automatically create issues on the Jira platform. So that's what my project does. My project is a command line utility written in Python, which takes in all the issues provided by the Metabob's API on a specific repository, and it automatically creates issues in Jira. So when I run Python in.py, and in the workshop given by James, you can see the list of repository. And if we take Scrappy, for example, the repository ID is 72. And when we write 72, as you can see, we're getting responses that the issues have been created. So if we actually go to the Jira platform, as you can see, new issues have been created. Yeah, as you can see, the title of the issues, the name or the type of the issue, the path to the issue file, the line number, the line end, and also the explanation. So this is my project. There are few improvements I would personally like to do. Or you can attach a machine learning model which would predict the priority of the task, so that it would be, if it's a higher priority task, more attention and a quicker attention would be given. And also, since this was I had to work in limited time frame, I made a command line utility to make sure that show that it works. In the future, I would create a front-end application using React or some sort, and also have authorization for both Metabob and also the for Jira, so it will be more secure and a robust application. So that's my project, guys. Thank you so much. Thank you so much.
Vishal, thank you. Thank you. Judges, go ahead. Take it away.
A very good idea, especially that you haven't used the Jira or using the API of the Jira before, and then have this idea. Just on the last point about you said, hey, if I have more time, I would do more prioritization. What would be a kind of how do you prioritize the ticket if you have more time? Like you said that you would use machine learning. I'm just curious, what's on top of your mind? You don't need to elaborate, but just whatever on top of your mind.
Yeah, sure. Thank you for the question. Like currently the script, like you have to manually store the your email ID and the API token of Jira on like a separate config file in a Python file. Which I don't want to do that, because if you're running it like like a personal script, it's fine. But if you it's better for, like, if you want to advertise as a tool to different companies, you would like to probably have it on a website and have authorization provided by Jira and like Metabob in the future. So that will make the this tool really secure. You could have a machine learning model which could be trained on like the various issues that have been created, and have a predictive model which would based on the new input would predict the type of priority it would, and it would send that type of priority as a part of the data to the API to the Jira.
Thank you.
Okay. Oh, Abhi?
I don't
Go
think
ahead.
there's any other questions. I would like to say that this is a pretty interesting idea overall. And then also, have you used the Metabob application before?
Not really. This is why it was this hackathon actually helped me expose to that. Like I said, I was actually intrigued by the models it was using and the stuff it could do.
All right. So I mean, yeah, it is. We actually don't have support for Geo as issue tracker right now on our actual application. So this is definitely something that like kind of shows what we could do for that. So that would be great, actually. Thank you.
Thank you so much, guys. Thanks.
Yeah, I think it's quite interesting. Obviously, for people like me, writing a lot of codes, obviously we like to have certain quick ways to, to publish the system. Then other people they can view quickly. And obviously, I think in the future development, maybe you can add more functionalities, to supporting more different ways that we can dealing with the bugs and promote, cite to other people's things like that. Obviously, as you mentioned, I think there might be some interesting ideas to explore certain machine learning models to find certain patterns within those bugs and maybe provide certain recommendation. Things around that. I think it's quite interesting. There's a lot of potentials out there.
Thank you so much. Thank you.
Awesome. All right. Well, yeah, Kushal, thank you so much. The next project will be Perceiver. So if anyone would like to share their screen for that, please go ahead.
Hello.
Hello.
Hello. Good morning to all the respected judges. My name is Ayush Chopra, and I am here with my contributor, with my friend Dhruvraj, to present our quite beginner presentation, beginner project, because I think I am also a beginner in programming. When we were introduced to the Metabob API, first of all, it was like difficult for me and my friend to understand what type of schema the Metabob API is trying to give us. So basically, first we try to understand the structure and the properties which Metabob API is providing us. Then, like Hacktoberfest is going to come in the next month, and being a beginner, I also have to contribute there. So I thought that it would be a great idea if I can distribute the projects and graphically analyze the user that which project has the much more amount of issues. So basically, I have created this graph which is using the ID of the repo which is provided in the Metabob API, and here this is the number of issues that that repository is facing out. Like 9th ID number repo is facing 17 issues. Similarly, I can also check by creating a loop in the program in the JavaScript that which repository ID is facing how much number of issues. Basically, on the x-axis we have repository ID, and in the y-axis we have number of issues. Also, with the help of JavaScript, it would be great if I can give a brief explanation to each repository having ID, and we were given with the URL, the URL on which we can request for our API, that using reference ID. So yes, I tried to request using that URL and a reference ID, but basically I know I have to make some improvements in my project. Like I need to dynamically add these contents using JavaScript, and I tried this, but I was partially successful. Basically, after I submitted my project, I tried more and more on trying to fetch these data using their ID and their reference number. Basically, I was able to just get that data for reference ID 905. I'm going to show you this improved project. I know I have not submitted this, but I need to show this because basically this is going to fetch. It will take time, like 1 to 2 seconds. So yes, this is for 905 reference ID. I have fetched whole data from Metabob API. So yes, working with the Metabob API was exciting. I am going to surely I'm going to like work on this project more so that I can give the user more information about the project they can contribute to, and know more about what type of project they want to contribute. uh, I have understand the need of this project, that I have to make some improvements, and yes, I am working on it. I will do this. I have also created a beautiful beautiful UI. If it is like, this is the data section, this is service section. Here we have tell a little bit about the project. So yes, this is.
Awesome. Ayush, thank you. Judges, go ahead.
Yeah, I think it's an interesting idea, but it's good you actually find certain ways to visualize all those information. But I think from people who use a lot of BI software, dealing with visualization, I think my recommendation is obviously it's better to providing more knobs or more features that people they can look at the data from different dimensions, which is quite important, especially they're doing slice
sir.
and
Yes.
like yeah, I think yeah, a lot of
basically, sir, I try to deliver that information what you are trying to say, like location, the category of that problem, but I was not able to successfully fetch those APIs from like Metabob API. I tried for one, like I showed you here, like this, but I was not able to successfully get those and dynamically receive those on the front end. But yes, I am working on it. I tried, but I was not successful. After submitting, I got some idea, and yes, I did.
Sure. Yeah.
Yes.
Yeah.
Yes.
And also, I think sometimes you give people a lot of options to visualize this data. Sometimes, if you can do a little bit more data pattern analysis, right? If you see certain common issues, things like that, you can proactively push those visualizations as a way to let people know before they begin to kind of doing those slice and dice analysis.
Yes, sir.
Always very interesting to to see the visualization on bug-related issues. But good job.
Thank you, sir.
Hey, you mentioned that the API is good and confusing. Any quick point about the confusing part? The documentation, or are you talking about the layout, or what are you thinking?
Basically, sir, I am a beginner. I have learned JavaScript, fetching APIs and all. So I have always interacted with small APIs and small requests. But when I was reading the documentation, there I got a file by the extension .json. So when I visited that web page, there I found that it was quite confusing for me. But later on, I understand that it was just representing the schemas, and the real part is not here. So then I just searched the documentation, and I got to know that yes, I can fetch data based on the ID of the repo, and also based on the reference ID, I can extract all the problems faced by that repo. So yes, I made a hit and trial method. From repo ID 69 to repo ID 101, it was giving valid repo. So yes, we can also extend this graph to understand more, and we can also like fetch more and more data. But the confusing part for me at the first glance was that I was not able to understand that .json file. But after that, it was all quite good, and we tried to make this small project.
Thanks for the clarification.
All right. Well, overall, it was a pretty like interesting idea to show the visualization like this. The only I guess suggestion I would make is while we do have the repo IDs for internally on Metabob for keeping track of which repositories you're looking at, we also include the repo name. And in most instances, I feel like that would be a lot easier for people to just understand than number 73 has 83 bugs in it is a bit complicated. But if you say it's like Rich has that repo has like three bugs in it, or like Flask has like 6 things that we've identified.
Yes.
That would be a lot more understandable. Other than that, though, everything else was pretty good. And as a a newbie or beginner, this is definitely something that is like fairly well done considering.
Awesome. Ayush, thank you so much. You can go
Thank you,
ahead
sir,
and...
for giving this platform. This is my first hackathon, and I've tried my best, and I will try to make this project more and more good and more advantageous for beginners. Thanks a lot, sir.
Awesome. We appreciate it, Ayush. Thank you. Okay, the next project is Metallizer. So Metallizer, feel free to go ahead and share your screen.
Yes, sir. Yeah. Is it visible?
Yep, perfect.
Yeah. So when we initially started this, so we didn't know much about APIs and stuff. So we chose Flask for it because we know a bit about Python. We do usually use Python for some kind of CP programming and everything. So we started with Flask because it was so using the Flask API, we are fetching data from the Metabob APIs and everything, and we basically made a kind of a graph models so to understand how the data is or how it interacts. So what we used is we used another Google's API where they have these kind of pie charts and bar charts. So they offer these kind of services. So we use that to visualize the data. So after this, what we did was we used this kind of all this whatever references we were able to get or understand you were able to get in the LDA. We actually tried for topic modeling based on the explanations which were given in the API. Each problem had some explanation for it, the category and the explanation. So using that, we tried to do a sort of a topic modeling. So
so we actually came across we came across the thought when like Ben Reeves was in his workshop. We talked about finding the topics in the GitHub commit messages. So we thought we could implement something similar to the explanations, and we tried with it. So basically what we did was we collected all the explanations using the API for all the problems using in the entire data set. And after that, we went through an offline process where we tried to find 5 topics like using the LDA algorithm. So we tried a couple of things like to get the best output, we tried changing the number of topics or the number of words which describe a topic, and also the number of iterations the algorithm runs for. And we tried to come up with a stable point where we thought the topics are good now. And we just stored the model weights, and in the online process where you provide the repository ID and the problem ID, we try to associate it with a particular topic.
So what we did was for some repo and some problem, we were basically analyzing based on, okay, so that kind of problem statement, what could be this error or what could be the most closest to thing to it. So we try to correlate that kind of thing. So
can you remind me what is 69 and what is 609 respectively?
We're really sorry we didn't explain that. So basically, we didn't have enough time to make a UI out of it. So we went with the URL itself. So 69 is the repository ID, which is for Flask, and 609 is the problem ID. We can show you the message we got, message there for the correct ID.
So I can show the code, like how we are basically doing this, how we are getting it. So here is it visible? Is the code visible?
No, it's stuck actually. It's we're still seeing the syntax error screen
Okay.
with the Bob image.
Yeah.
One of the problems we faced was after clustering them into different topics, we had a hard time naming the topics. So like, there were a lot of in overlap between the topics, and it was hard to give them a definite heading, but we tried our best. So we use, like, based on the weights for the text we get, like the explanation, we try to find which topic has the maximum score, and we print that topic as the output. So here you please go ahead.
So for the topic especially, we actually tried narrowing it down as much as possible. Initially, we started with a larger number of topics, but we faced a lot of problem because especially due to some of the explanations, the words were getting deleted. Suppose if the explanation was yes, I can. So what the algorithm does is it removes most of the redundant words like yes, I, and for, those kind of words. That's where we faced a lot of problem because it was removing certain words like if also, where suppose the explanation is the if statement is wrong. So there we were facing some issues. So we had to work around we had to deal with those kind of issues also.
So the general process is that, as you saw before, we take the repo ID and the problem ID, and using the API, we get the explanation text. And the first thing we do is we remove the punctuations from the text and lemmatize it. So it's like causing, make it cause, like may remove the past participles and stuff. Then after that, we try to we have a list of words, like from the corpus of data, we have a list of words, and we try to come up with a matrix which is called the dog term matrix, where each item is the number of occurrences of the word and the word ID in the dictionary file we have. So we made use of a dictionary file where we had all the important words we thought was from the document, and we made a list of tuples where in each tuple you have the number of occurrences per word and the word index. Then after that, we pass it through a model. Could you come down a bit? So after that, we pass it through our model and we try to find the highest score it can be. So for the current explanation, which is it more closer to the 5 topics we have, and we return the topic ID basically. So you could take a look at the topics also. Could you scroll up?
Yes.
So these are the topics we nailed it down to.
So this was mostly a trial and error process because we weren't able to get it there down specifically. So we had to just try inputting with various values and see which works the best.
Like I said before, like we tried a lot of things to better optimize the output we got. We tried fine tuning with the alpha and beta parameters. We also tried batch wise, running the algorithm batch wise. And after doing all that, we thought this is the best thing we could come to.
Yeah, that was pretty how did you enjoy, was this your first exposure to training a LDA or a topic modeling system?
Yeah, this is the first experience where we're not new to the concept of NLP. We've done some chatbots before, but this is our first time using an algorithm called LDA.
All right. As a quick disclaimer, I don't think we explained too much about how we're generating the explanations with Metabob. We're actually using a sequence transformer to create these explanations. So there may be quite a bit of noise actually in the explanations that we create. We try and make it so they correspond to the basic understanding that we have overall. I think Ben just in his workshop went over roughly some of what we do technique-wise in order to try and isolate different types of bugs. And yeah, sorry.
No, I wasn't saying anything. But he also mentioned that the one you mentioned, the sequence transformer and the SageMaker one requires a lot of data. And we had only access to 20,000 lines of explanation.
Yeah, that's understandable. What I'm saying is that what Ben was describing was basically what we're doing to some degree. Any model that you run after this is an AI model built on top of the outputs of other AI models. And then before that, our input data is the actual input source code from GitHub, and that's human generated. So there's the only this isn't a negative statement, I guess you could say. It's more of a if you weren't aware earlier, please be aware now that the data that's being generated for the explanations is from an AI, and therefore will not necessarily have the same topic features as something generated from a human's understanding of the language that you're then trying to embed in inside of a topic model. This is an AI's understanding of an AI's understanding of a human's understanding of some underlying causality between words, and there's a risk inherent in doing that. There's some biases that you need to be aware of if you are going to be using this technique on AI generated data. That's different from human generated data. So that's just a note, more so than anything else. Overall, I think the project is very well done. There is a couple of it would be nice to have a UI. I understand that training an AI model or doing the actual topic aggregation can take quite a while. So it's understandable if it took a lot more time than you may have expected to get that set up. But overall, I think the idea is good. There's probably a couple of other things that you could do to improve it, but the effort's very visible.
Thank you very much. Sir, can I ask you a question? So your AI basically goes to code and suggests a better coding styles, right? So how does it do that?
Yeah, so if you recall from Ben's workshop, I do believe he went over generally what our process is for that, but I can give you a quick overview right now. Basically what we're doing is something very similar. So we're looking at the different code changes that were made on open source repositories, and we have access to quite a substantial number of these. We isolate the underlying cause using a variety of techniques, but there's also this topic modeling system that we're implementing. But there is quite a bit of manual labeling that also needs to be done to try and bootstrap that process. And then using that, we have a couple of different, or rather, we have our bug detection technique, which is a fairly sophisticated AI technique called graph attention networks to isolate different patterns from the source code itself based off of different parameters and factors as they're correlated to each other. And then we assign those to different bug topics that we've identified from the code change or the commit history or the pull request messages that were associated with it. And that's how we're predicting in different code bases whether or not something is or is not a bug. And then using those topic messages and the code itself, we then try and generate explanations if it's not very straightforward or simple. and then we send those out to a transformer type model to create explanations for each one of these. And that's what's in the explanation field most of the time. Some of them are messages from like aggregated set of more standard rules that we're also using. But as time goes on, we're deprioritizing. So it's mostly AI outputs. And if you guys were looking at the data and you would see like, yes, I can, or no, I can't in the explanation field, those, I guess, are Easter eggs because sometimes we don't have enough context information for a particular type of problem, and the AI model that we're using just generates some garbage, and we're trying to also remove those as well, but it just takes some time.
We kind of assumed that that was the reason, like, okay, this may be some human written or something like that, because of those weird values in between. So like, so we thought like, okay, maybe we can, you know, get something out of it. We actually remove those kind of values and then we try to work on it.
Yeah, overall, that would be the appropriate methodology to do for those kinds of things, because they are like outliers, but that's basically how it is.
Yeah, okay. Thank you so much, Metallizer. We just have one final group here. It would be Bob Searcher, or one final project, I should say. So Bob Searcher, whenever you're ready, please share your screen.
Is the screen visible? Hello?
Hi. Yeah, we can hear you.
Yes, is the screen visible?
Yes, we're just seeing a mirrored image of the Zoom screen, though. We don't see your project.
Yeah, okay. Now is it clearly visible? Yeah, okay. So our project name is Bob Searcher, and it might be one of the non-fascinating ones to say the most, but like we are fairly new to the idea of APIs, and like we heard the term for the first time in the workshop, so I think we did a pretty great job. So this is a project we just basically made an API call to get all the data from the Metabob API, and we added on some issues from our part because we could not get the issues from the API itself. So we added on some personal, like randomized issues to each data set, and then we basically created a tkinter this thing. One second, just let me look the code. Yeah, we basically opened up a tkinter window and had a text box in it. So what this text box does is it takes in search text. The search text can be an error type which we have manually input in the data. So for example, if I put assertion error and use this button print over here, so it prints out the repo ID it is there in and the name of the repo. So initially what we were trying to do was we were trying to implement this on a web page. So we made all the HTML and things, but using JavaScript was a bit new for us, so we could not implement it properly, the GUI part. So we ended up making a tkinter window in Python itself. So I know it's a bit okay, underwhelming, but yeah, we are fairly new to the idea. This is our project.
Okay, awesome.
It's a
Thank
good.
you.
It's a good try. I'm assuming this is the first time you use the API as well, right?
Yes, yes. Thank you.
Yeah, it was a good like underlying idea, I think. Obviously being new to like using APIs or this whole process in general, like obviously adds a lot of extra complexity. But overall, I think it was fairly well done considering.
Thank you, sir.
Okay. I think that wraps up the presentations. So thank you all so much for staying with us so late. I know it is not the kindest hour in IST at the moment, but the judges are going to convene, and we will meet back here once we are done for the final ceremony to announce the winners. So we will just message on Discord when we are ready. It's going to be the same Zoom link. And yeah, Rika, do you want to go ahead and?
Yeah, so since it's so late, I know on our timetable it says the closing ceremony is at 4 p.m., which is 1 hour from now. We will try our best to maybe even start earlier than that once it's ready. So just please just keep in mind and then maybe check Discord time to time. We'll be announcing there.
Yeah, we'll try to consolidate as best we can, folks. We know it's late. So yeah, just hang tight and please be on Discord, and we'll announce when to join back here. So yeah, I think that's it. Thank you so much. These are fantastic. We really appreciate it, and we will see you very, very, very soon.